In question 6 of this series, we're asked, a certain investment in bonds had a value of $248,000 after 4 years and $260,000 after 5 years at simple interest. Find the principal amount invested and the interest rate. So we have an investment that was made 4 years ago. We don't know how much was invested initially, and we don't know at which rate, but we do know that after 4 years, $248,000 was obtained, and after 5 years, $260,000, which is a jump of $12,000. Our goal is to construct two equations because there are two unknowns here. We have the principal amount that's unknown, which is represented by P in the simple interest equation, and we don't know the interest rate either, which is represented by N in this equation. So for every unknown, there needs to be an equation created. Let's construct an equation for create the 4th year, one for the 5th year. So at year 4, we are told that there's $248,000 in this account. That represents the amount, 248. So I've simply replaced y with 248, and I can do the same thing for year 5. So I'll create the two equations at the same time. We have $260,000 after 5 years. P is what we're looking for, that's the principal, the initial amount invested, times 1 plus N, which is what we're looking for. And for this equation, T is equal to 4, and N times 4 is 4N, and N times 5 is 5N. We have two equations now with two unknowns. We have to solve for P and N. There are several strategies that you can use to solve for P and N. A lot of students might solve for P in both of these equations right now and set the two P's equal to each other and isolate for N. Although the approach that I'll take is first expand both of these equations. That way I can use the addition-subtraction method afterwards. If I expand the right side for both of these, I end up with 248,000 is equal to P plus 4PN, and 260,000 is equal to P plus 5PN. Like I mentioned, I can now use the addition-subtraction method to eliminate one of my variables. I'm going to eliminate P, and I can do that by subtracting these two equations. Subtracting 248 from 260 gives us 12,000, or negative 12,000. P minus P is equal to 0, that goes away. And 4PN minus 5PN, that is equal to negative PN. You don't need to put negative 1PN. It's assumed that that 1 is there. Since there's a negative on both sides, I can divide both sides by negative 1 or multiply both sides by negative 1, and that will eliminate the negatives, leaving us with 12,000 is equal to PN. I'm going to give you a second now to think about what to do with this PN. Normally when we add or subtract a linear system, we end up with a number equaling to a variable. This time we have a number equaling to two variables multiplied to each other. Some students might want to isolate for N or P at this stage and substitute it back into one of the equations, although it's much easier than that. Take a look at the two equations that we generated earlier. Both of them have Pn, so I can substitute the content of Pn into one of these and I can solve for P. I'm going to substitute 12,000 into the first equation. Notice what happens. We have 248,000, that doesn't change, is equal to P plus 4 times, and I'm going to replace Pn with 12,000. This gives me on the right side P plus the product of these is 48,000. Bringing this over, this term, so I can collect like terms, I end up with 248,000 minus 48,000, which is equal to 200,000. This is the amount of money that this person invested 4 years ago. Now, to find the interest, all we have to do is substitute this value into this equation, namely into the P. Look what happens. 12,000 is equal to 200,000 times N. I've replaced this P with this number. Now I have to isolate for this N, and that's really easy to do. All I do is divide both sides by 200,000, giving me 12,000 over 200,000 is equal to n. Using my calculator, 12,000 divided by 200,000 gives me 0.06. So the interest rate is 0.06. And if you want to represent this as a percentage, you just multiply by 100%, which gives you 6% interest. And so there you have it. That is how to solve word problems with two unknowns.